In this video, we're going to talk about coterminal angles. Two angles with the same initial and terminal sides, but possibly different rotations, are called coterminal angles. The first example that I'm going to look at is an example of positive and negative angles. Normally, when we look at an angle, we consider it with the initial side being on the positive x-axis and a rotation counterclockwise. So we would be looking at this angle, and let's say that this is about 150 degrees. But we could also look at this angle as having the initial side on the positive x-axis and the rotation being clockwise to where this is my angle, and this angle measure would be negative 210 degrees. Remember that positive angles have a counterclockwise rotation, negative angles have a clockwise rotation. Now, in my diagram on the right-hand side of the screen, this looks like it is about a 30-degree angle. This angle is showing that I have counterclockwise rotation, which is going to be a positive angle. I could also start at this initial side of my angle, go one complete revolution around the circle, and then continue going to get back to that terminal side. So I have one complete rotation, which is 360 degrees, plus another 30 degrees. So this angle is 390 degrees. The directions for the first few problems I have says to assume the given angle is in standard position, find a positive angle less than 360 degrees that is coterminal with the given angle. So I have this angle that I start with that is 680 degrees, and I want to undo one rotation, so I'm going to subtract off 360 degrees, and that gives me an angle of 320, and that is less than 360, which is what my directions are asking for. Now, if I start off with a negative angle, what I need to do is add 360 degrees, and that will give me a 320 degree angle. Now, sometimes you may need to undo more than one rotation. So on this next problem, I have 750 degrees as my angle. If I subtract off 360 degrees, that's going to give me 390. And that's still more than one complete rotation. So I can take the 390 and then subtract another 360, and that gives me 30 degrees. And there's a couple more things that I want to mention with that particular problem. First of all, if you know that two full rotations is 720 degrees, then you can just go ahead and subtract 720 and get your answer of 30 instead of subtracting 360 and then 360 again. The next thing I want to mention is mainly for the future teachers out there. But this is also a good reminder for anybody who is going to be going on to higher level math where you have to show your work. You need to be sure that you show your work in a way that is mathematically correct. I'm going to show you a mistake that students make quite often in high school or middle school math. Students oftentimes will know the correct procedure for doing the problem, but they do not know how to write out their math correctly. An example that I had seen quite often when I was teaching K-12 would be 750 minus 360, and that would give me 390 degrees. And I realized that's too big, so then you subtract 360 again, and you get 30. Well, the testing companies that public schools use in the past have called these nonsense statements. It's really what you're saying here is that 750 minus 360 is equal to 390 minus 360, which is equal to 30. You're saying that all those three things are equal, and they're not. 750 minus 360 is not 30. So you need to be sure that if you're a math teacher, that you are not writing stuff like this on the board so your students are not getting confused, and you need to be sure that your students are not writing stuff like this, because state testing will count off for something like that. And I've always counted off for stuff like this when I'm grading tests as well. So just be aware of that. The directions for our next set of problems say, assume the given angle is in standard position. Find a positive angle less than 2 pi that is coterminal with the given angle. Okay, this first problem, I have 29 pi over 5. So I need to subtract off one full rotation. Remember, one full rotation is 360 degrees, or 2 pi radians. So I need to subtract off 2 pi. Now what I would do is put this in the calculator as 29/5 minus 2, just not put the pi's in there. And when you do, you get 19/5, and then you go ahead and then stick the pi in there for your final answer. And you can see how I've entered that into the calculator. So now I need to decide whether to subtract off another 2 pi. So I need to determine if this number right here is more than 2 pi. Well, what I could do is go back to my calculator, click Math, scroll down, select decimal, and change my answer to a decimal. I see I have 3.8. Well, that's definitely more than 2. So I can subtract off another 2 pi. And I have 9 pi over 5. Now I know that 9/5 is less than 2, so I know that 9/5 times pi is less than 2 pi, so that's less than one full rotation. So that's the answer that I'm looking for. My next problem, I have negative pi over 8. I need to add one full rotation here, so I'm going to add 2 pi. And again, you can use your calculator, and I would put in my calculator negative 1/8 plus 2, and that would give me 15/8, but I want to be sure that I stick the pi in there afterwards, so 15 pi over 8. Okay, here I have a negative angle, so I know that I'm going to need to be adding 2 pi. So again, I would put this in the calculator without the pi symbol, and then just stick the pi symbol in my final answer. When you put this fraction part in the calculator, when you put negative 31/7 plus 2 in the calculator, you get 17/7. But we have to put that pi in there. And I can see that I'm still having a negative angle here, so I have to add another 2 pi to that. So that would be negative 3 pi over 7. And then add another 2 pi. So I have 11 pi over 7.